Good afternoon and welcome to Global SMT and Packaging Live show at Productronica in Munich. My name is Viktoria Rawinsky. I'm founder and CEO of Rawinsky GmbH, and today I invite you to join me for exciting panel discussion on topic from birth to death and beyond, the reincarnation of raw materials. We live in a rapidly changing world. For decades, the growing electronics industry has brought us higher living standards, better healthcare, and unlimited access to the informations. But do we ever think where the raw materials from this came from? Or what happens to them after the end of the life cycle? As they are not unlimited, I'm speaking today with two leading industry experts about the beginning, the end, and the reuse of raw materials, without which electronics manufacturing would not be possible. And my first guest is Chris Ward. He is a co-founder and director of Solder King Assembly Materials, leading UK manufacturer for innovative solder solutions focused on support excellence. He specializes in process optimization for electronics manufacturing. Welcome, Chris.
It's a pleasure to be here, and thank you for the introduction. That was fantastic.
My next guest is Anton Schmatko. He is head of finance and trading at MTM Rurzin. Formerly in gas and coal trading, now for 8 years creating value in the field of tin and precious metal recycling, boosting the sustainable and economic performance of companies in the electronics industry. Welcome, Anton.
Thank you, Victoria. Happy to
I'm
be here.
so glad to have you here and have a panel discussion with me on topic of materials, especially raw materials, and how to use it and also how reuse it after the end of the life cycle. And my first question is for Chris. How does the manufacturing process for solder products generally works? We all use solder paste and solder wire, but I have no idea about the manufacturing process.
So this is it. Solders are, yes, often overlooked, but an important commodity when it comes to PCB manufacturing. My opinion, as I said to you off camera, is solders are one of the most fundamental parts of the process, and without a good quality solder, you can experience defects down the line. In terms of the manufacturing process, we can have a look at, let's focus on solder wire, for instance. We know the makeup of solder is, especially for lead-free, would be, say, tin, silver, and copper. Currently, you can purchase these raw materials either as recycled, or you can purchase them as virgin raw materials. And for this type of, focusing on solder wire, you would simply blend these elements together, form them as a casted billet, and then to keep it kind of simple, you would extrude it into a wire, and then it travels through various different processes, going through rolling mills, wire drawing, and eventually ending up at the customer's required size. That could either be, say, 2 mil or 3 mil for selective soldering on a large kilo reel, or you can go down to, you look at other THT applications, and you can produce it down to 0.7, 0.5, even down to 0.2 millimeter. And then you also have to factor in flux within the product as well. Like, flux is often overlooked, and flux is a technology that really helps solders perform to peak performance in today's demanding applications. So yeah, it's quite a unique process, and I'm really, really delighted to be a part of that.
That's a very interesting and exciting process. You should be very precise by manufacturing, right?
Absolutely. Solder King, or solders, they have to be manufactured, or they have to be precision manufactured. They have to be consistent, because each individual solder joint is incredibly important, and without that level of consistency and without the correct raw materials, that's when you're going to experience defects and challenges.
And is the quality of the raw material a subject of serious deviations, or is it more or less consistent?
I suppose you can get deviations within raw materials, but it's about having the correct supply chain. It's about working with the correct partners, and it's about having the correct raw materials to ensure that you have a consistent product throughout each individual batch.
So, and the quality of the raw materials plays a major role, I understand. If you see some deviations from the raw material side, what do you do?
That's exactly it. So the aim is to avoid any type of deviation from batch to batch. As you can fully imagine, the importance of tin within a solder wire is, well, it's second to none, because the majority of solders are based on 96 to 99% tin. So yes, choosing the correct raw material through either recycled methods or different means of supply are certainly very, very important.
Anton?
And as Chris already said, it's a question of having the right partners for raw materials, but also it's possible to use pre-alloys from recycling when the alloy and the purity is consistent. It's good for economics, but also for environment to use pre-alloys from recycled solder materials, like from pastes.
The electronics industry is currently in, let's say, stormy waters, so the situation is challenging, and we face uncertain access to many raw materials and strange price changes. And my question is, what's the best way to deal with this? Should we buy more raw material in advance, or should we reuse or use recycled materials? What do you think?
I think it's often several things, right? So, of course, the volatility of prices, but also availability is getting higher. What's good is to have partnerships between electronic manufacturers, solder manufacturers, and a right recycling partner, because we speak here about material flow, right? So it can be first raw materials, but later it's in solder, later it's recycled material. And if it comes to the availability, let's say here in European market, it's more stable to have also a source of recycled material, because recycled metals are not imports from outside. Yeah, they are here in Europe. You can keep the material flow, let's say, clean. It helps to have better prices and availability. So a good partnership is important. And as you mentioned also, what's sometimes possible for manufacturers, for electronic manufacturers, to have call-off quotas. So you have one price maybe for 12 or 24 months fixed, and then you are not as much affected by higher prices.
That's right. What do you think, Chris, or what do you use to do? Do you buy raw materials in advance?
Yes, we do buy raw materials in advance, but I would like to kind of double down on what you're saying as well, and it's sustainability. I believe it's an important topic that we should all be actively working to improve. We should be looking to have more sustainable processes, and again, the end life of a product is very, very important, and deciding what its next stage of life is going to be. But yes, in terms of, can you guess the marketplace, or should you buy materials in advance? In today's climate, it can be tricky, but again, with good partnerships, good suppliers, you can stick to having call-off orders and keeping costs at a stable level. Yes, exactly that. So, yeah, it can be challenging, but then with the correct people in place and relationships, you can certainly ensure that results are consistent.
And what are arguments for using recycled materials besides greenwashing marketing? So I should say it is like it is. A lot of companies use something recycled just for to be able to say my CO2 footprint is good.
Yeah.
But besides this aspect, what?
That's a very good point, because if it comes to metals, the impact is real, because metals can be recycled again and again, and the CO2 reduction is very high, because if it comes to raw materials, you don't have a pure metal block in the earth, so you have to mine it, you have to clean it, you have to purify it, you have to transport it. If we speak now about recycled tin, let's say pure tin from recycling, you save around 80% of CO2. If we speak about tin silver alloys, you speak about around 86% of savings. If it comes to precious metals like gold, 99% of CO2 are saved.
Oh, wow.
It's very high, because the impact of mining, we as a society, we need it, but it's a big impact on the environment. If it comes to recycling, of course, you have to remelt it, as with raw materials, but the impact, you save a lot of CO2. So it is not greenwashing, it's real CO2 reduction. And as already mentioned, material stays local, material availability is better in the markets, so you can count on better prices and less or more stable prices in your market as a manufacturer, and in the end as someone who buys alloys, a solder for the electronical production.
And you are more independent, right?
Of course. So more and more companies ask to have the solder material out of their residues. So there's a in-house or material flow. It's also possible, but the good thing is it's measurable and real results, good for us society and good for the European economy.
And I know about a research project for reusing the solder balls. Anton, maybe you can tell us a little bit more about this.
So solder balls are very interesting product, right? So we had a successful research project with partners. The point was to find out if it's possible to, let's say, clean the paste to receive back the balls without remelting it. It is possible, so it was successful. You can clean up the flux and also check on the quality of the balls. It is at the moment not an industrial process. We are still in development, but maybe it's something for the future. So new solder material is coming to the market, so also new recycling solutions are needed, and that's what we try to support. Also, new alloys are on the market, paste with balls of different alloys. So separating the balls is even more important with this kind of product. So let's see what in the future will be possible on industrial scale to support the recycling process.
Does the size of the solder balls play a role for reusing?
I mean, a big one, because at the end, for a new paste, you need the same the same size. You don't mix the size of the ball. So it is important to have a quality recycled process. That's one of the challenges. And so that's why we are hoping to get better in the industrial scale in the future.
I can imagine you have some recrystallization or maybe some aging effects on solder balls during the time. How to avoid or how to fix this problem?
Very good point. I'm unfortunately not too much into the research engineer side of this, but you're right. That is what was part of our project to check that, because purity and quality is, as Chris mentioned, that's what's important. So that's why it's a little bit, there's a difference between what you do in your as a project or industrial scale, right? Yeah.
So Chris, from the industrial view,
Yes.
what would you say to use the recycled solder balls?
It's exciting, isn't it? if we can all move towards, I'm going to say, a more greener future, a more sustainable future within electronics manufacturing, then it's a positive change. Yes, I'm sure you've got challenges there, but it does show that we are moving in the correct and most economical method of continuity of supply for, say, solder manufacturers and electronic manufacturers. So, yeah, I think that's a real positive step forward, and I do wish you guys all the best with that, because, yeah, you'd certainly have a few exciting solder manufacturers anyway.
Anton?
And because I like this product, paste and solder balls, for me was interesting. It's not, let's say, from us, because we don't produce the powder, but from a manufacturer. There are even differences if you take raw materials, depending on the area where the mine was. We speak here about impurities of 0.01%. And because the balls are getting so small, there is a difference from which area in the world the metal was coming, because the trace materials of 0.1001% makes a difference how in the production the reaction to the balls is. So it's on the recycling side, but also on the raw material side. It is an industrial process that had to be handled in a right way, so the quality of the end product is same, and then the only possibility to have a quality solder product. So both is important, the raw materials and recycling.
Is it possible to mix raw materials with recycled materials to get better quality? Is it something which is state of the art, or is it?
So recycling is not new, right? If it comes to, let's say, copper and other metals, it is done for centuries. The only thing what has changed now, we have always mixed materials in the worldwide market. It's not traceable, and it's not measurable. That's what may be now changing, or what also we do. We do it measurable. We want to show how much CO2 is really saved, how recycling is impacting the process. So there was always in Europe maybe 10, 15, 18% of recycled materials together with raw materials. And now there are products 100% used of recycled materials. So the quota is going up, and we try to help to measure it, the impact of saved CO2.
Chris, do you think we need more overthinking process to get more acceptance for recycled materials?
I believe if we maybe look back 10, 15 years ago, there was maybe a little bit of resistance. However, in the current market, I would say there's some hot trends, and very rightly so. You've got reliability and sustainability. Sustainability and reducing the carbon footprint, and you've got the likes of EcoVadis, who are basically ensuring that companies are running as sustainable as they can do. It's certainly it's well received, and rightly so, because, like I say, it is a topic that cannot be ignored. So as long as we can ensure that the quality of product is the same, which is evidently clear, then I don't see any issue in, like I say, working towards a greener future and producing more sustainable, cleaner products.
Right, because the electronics manufacturing sector is still growing, right?
Yeah, absolutely. Do you know, you see here you've got best-in-class equipment. You've got world leaders all flying the flag, and solders and the raw materials, we all have to keep up with the demands of these suppliers, manufacturers, and respond to the customer's needs. And yeah, I would say that pushing forward with sustainability is certainly a route that we need to go.
Anton?
I think it's now 5 or 6 years ago, Apple called recycled tin the better material. So at the end, we have the same quality and purity. But you need, as an industry, we need good partnerships, a good partner for recycling. That's why also the quality of recycled material is getting better. We have companies like us who are not just from all kinds of sources doing the recycling. We are specialized on scraps from the electronic industry. So the alloys and the purity is close to the alloys you need for the production and the market needs as a solder material. So new partnerships, new material flows means better quality, and at the end, both is possible to blend, to use, and it's kind of not on their fields the manufacturer are producing. The EMS companies are doing the electronic manufacturing, and we do the recycling. So it's a win-win situation for the market.
Win-win-win situation. That's great. If you would have a wish for the future, what would it be?
It's a big question.
I know.
That is a big question. A wish for the future and this topic. I would like to say stable, continuous, efficient supply of raw materials. No hiccups day to day, and just a nice, steady, level playing field so we can all enjoy, build towards a more sustainable way of manufacturing.
That's great, Anton.
Long-term partnerships. I think that would help to all market participants, not doing decisions on short-term development, right? So like jumping to or reacting to the market volatility, because at the end, when we have real long-term partnerships, everyone benefit from availability, from lower prices, because you can plan the process, and if something like problem in the worldwide markets, transportation, you have a stable source of materials.
So thank you for being my guests here today and for a really interesting and exciting discussion.
Thank you very much.
Ko Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Ko Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.